Hi there. One of the basic features of a shell program consists of properly sending data to the operator's console during its runtime. This can prove to be quite useful when the script launches many commands in a short time, or by contrast, when they have a particularly long execution time and we need to monitor its execution stages. In this fifth lecture, we're going to approach the techniques for delivering data as output from a shell script. Upon completion of this module, you will be aware with the following: managing the attributes of the shell variables using the typeset command to initiate or alter these attributes, bringing data on the screen with the print and the printf commands, adjusting the format of the output information by properly quoting data. Learn what terminal is and what are its capabilities related to program output, description of the typeset utility and how you can use it to change the order of appearances of messages on screen, and we'll end up by checking out another powerful control in Unix, the STTY command. There are many features available in the POSIX shell to help control the presentation of data to the screen. In most situations, it is important to display information in an easy-to-read format. The format for the data can be stored as variable attributes or changed for output. Please meet the typeset command. It can be used to enable attributes for variables, thus controlling in a certain measure the way the variable is displayed on the text console. When it comes to get back to the initial state, all of the typeset options may be disabled by using the plus sign in front of the switch. For instance, with the -L option, variables can be assigned the left or right justification attribute in order to justify on the screen the text stored in the variable. In the following slides, we're going to see several such attributes and their usage as well. In short, a POSIX specific variable can have several attributes which can control its appearance. Here you have an enriched list of the typeset specific options meant to offer details for the previous slide contents. Apart from the ones we have already shown on the previous slide, you can spot a similar justification for numerals, the zero padding effect and zero stripper, respectively. Obviously, this is about specific controls for numeric variables so they could properly fit in columns on the console screen. Although we know that variables in shell are always stored as strings, we are about to discover in the next examples their attributes, which we can use in order to make them variables behave as close as possible to the typed data. With this program, I suggest a simple short exercise consisting of data format alteration for two variables, which are going to be fed in by some control console input. A simple modification for start is to convert their contents to uppercase. And then, in the other case, by using a third variable, which is new left name, we are about to limit the length and to properly set its place on the screen if it ever gets fewer than 6 characters. Furthermore, we'll see what happens when the longer names are used with more than 6 characters. Right, so now quickly get your hands dirty with code. There are several commands which can be used to control the output text formatting. In the previous example, the contents of variables were set to a specific format. It is most desirable to preserve the format for variables when displaying their output to the screen or storing them in a file. Judicious placement of quotes within the print command or use of the formatted print command with its extended text format capabilities will help preserve your format. In the following slides, we will emphasize both the good usage of quotes and the special characters that may be used in the printing of formatting lists. Characters called escape sequences. These sequences can produce some additional output to help control the format on the displayed text. You must use double quotes around the escape sequences. As we know from the previous chapter, everything being closed in simple quotes, apostrophes, is no longer interpreted by the shell. In this table, you can see just a few escape sequences. Some of them are pretty much used within the most of the shell programs. Others are inherited from the times when hardware consoles with integrated audio capabilities were largely used. Those which are still commonly used are appreciated among the programmers who write and use interactive scripts where they extensively process the data fed from the console. Others are simply indispensable for messages intended for logging purposes. The example on your screen suggests a quick but comprehensive study about the formatting options for a variable consisting of 23 characters. The printf command is a tool which can be used to create formatted output from data subsequently affected by our printing instruction. This can be useful if you do not want to change the contents of a variable but simply want to display it differently than it is stored. The C-inherited utility, that is the printf command, normally uses argument in pairs. The first argument is a standard formatting code, and the second argument is the very string to be displayed. You will always recognize the formatting sequence by the % symbol followed by an optional letter, also known as the flag character. The dot symbol from the commands on the 8th and the 21st lines as well is a trim directive which truncates the targeted message if its length is greater than an expected value. The numbers are supposed to control the desired field width for the displayed information. Then we can notice the so-called conversion letter, which in this case is only set to S as in string. The comments which you see near each printf command are in my opinion sufficiently meaningful to make you an idea about what was the programmer's initial intention in this example. Using the double quotes all over the programs within this course is intended to demonstrate how output formatting works. You need to know in detail all the shell's quoting characters if you really mean to carefully arrange text within your output messages. There are two types of quoting control available in the POSIX shell, and these are in the single quotes, respectively the double quotes. While you wouldn't feel much difference using them for plain genuine strings, there's another story when it comes to enclosing variables. That is because the double quotes won't prevent the shell from expanding the variables between double quotes, but on the other hand will not allow to the shell to interpret anything encompassed by regular ticks. Okay, so far. Now, another particular symbol used for this kind of control is the / character, known as the escape character, which prevents the shell from trying to interpret the immediately following letter. In the displayed program, double quotes are fed to the print command, but they're equally useful in combination with the echo command. They allow variables to be quoted and their original format preserved. So keep in mind that the contents of a variable is still correctly substituted by the shell, although the double quotes lead us to think otherwise. This will not work in the same manner for the single quotes. Now, what we are about to discuss in the further slides is not very much useful for standard batch script shells. In fact, we are now covering a very unusual domain, the interactive scripts, which use special displaying effects in order to have more impact on the monitoring user. Such features are bold text, underlined text, blinking messages, text brightness dimming, and others like this. These are common on many of the terminal types that are supported by the Unix environments. In fact, thriller movie with computer screens can very much emulate these features. So this discussion is not limited to the POSIX shell, but it is useful in many situations when you need to have the shell script control the appearance of the text on the screen. Okay? So feel free to skip the next 10 slides if you are not interested in exotic display features by Unix. Right, here we are. How are we supposed to deal with such features? We need a little background information here. Now, users that run interactive shell scripts are normally using some type of terminal or terminal emulator. Most of the terminal emulators support the use of a list of special control sequences to both allow and control the appearance of their display. There are three main aspects of the terminal that need to be understood before you can select the appearance characteristics of your output. What features are supported by your terminal or terminal emulator? How does a particular feature change the display appearance? Which command enables or disables the feature? The previous three aspects are available with the following Unix commands. Untick, which produces a listing of terminal capabilities, also known as cap names, based on your currently set term environment variable. The untick command uncompiles an internal Unix binary object called the terminfo, as in terminal related information, into a readable format. The listing, which is output, displays the capabilities of the current terminal type as defined by your currently system term variable. The capabilities listed should be cross-referenced against the man page for terminfo for an explanation of the features. Enter man terminfo, which provides useful details on what is called the terminal cap names, extracted from our Unix machine internal terminal information database, also known as terminfo device. Finally, the tput command, which is the command designated to enable the cap names and thus changing the whole aspect of your screen or to disable them respectively. Terminfo is a library and database that enables programs to use display terminals in a device-independent manner. The Terminfo database can describe the capabilities of hundreds of different display terminals. Overall, it is a collection of terminal-related files, each of them containing data related to a specific terminal display type. The information in a Terminfo specific file falls into following categories: terminal display capability and attributes, terminal display controls, also known as special character sequences, terminal special key definitions, such as function key character sequences. For each piece of information, a special word is assigned called a mnemonic. These words are the ammo for our next slide. In computing, typet is a standard Unix command which makes use of terminal capabilities. Depending on the system, it uses either the terminfo or termcap database, as well as looking into the environment for terminal type. The typet command uses the previously slide mentioned words, that is mnemonics, to invoke or display a terminal characteristic. The capability is referred to as cap names. The advantage of using the typet command is that it will apply to whatever terminal type the user is working at when he runs the shell script. The script, therefore, is not limited to being run on one specific terminal type. So here you have a small list of some of the most known and used cap names. We're going to use some of them for a demonstration, and you have several examples in the printed version of this course to play with. Very important notice. Special care should be taken when turning on special terminal display characteristics. That characteristic will continue to be in use even when the script has terminated, unless the characteristic is disabled or turned off prior to the termination of the script. Therefore, it's a good idea to turn off that feature when you're finished using it to control the appearance of the output before you exit the script or disconnect the interactive PUTTI session. Okay, we're getting back to serious things. We have on the screen a small script which dares to play with the typet command in trying to do some effects on your screen. Before we went bazooka, it's a safe script, okay? You won't break anything in your user profile if you copy this code into a valid shell script file and run it. Basically, we have some data collected from the standard input by the read command. Before we actually collect that, we throw on the standard output a very polite message giving a clue to the unsuspecting user about what's currently happening. So please enter some data, and then the user will send in some couple of word string, which is going to be stored in the data variable. So far, so good. But look what we have done before we sent that message. We activated the standout display mode, didn't we? So our text on the screen will show some light on it, right? Now, before we did some current control by showing to the standard output what's in the data variable, we do another thing. We change the displaying capability by the SMUL mnemonic, which will activate the underline effect before effectively displaying the you entered column some data thingy. Alright, so now we've seen the light, have we not? Therefore, we bring the things back where they were in the first place by the SGR0 cap name. And we're looking good, ladies and gentlemen. Apart from the ones that we have just experimented, there are several other terminal cap names that can be used, this time to control the position of the cursor on the terminal screen. These would give the capability to position output text exactly where needed. This is particularly useful for those text-based applications which need interactive pagination and data arrangement besides the special lighting and all the previously named special effects. And here you have a small list of the most commonly used cap names for cursor positioning. Before we start discussing this program, you must find out another small clue related to how terminal emulators work. Whenever you have a PUTTI session opened, you can call two variables, the lines and the columns variables. Depending on your current window size, dynamically adapted values are assigned to them. Due to the fact that they're only available during an interactive session, it is highly probable you couldn't use them explicitly within a script. That is precisely why I have fed those values in two custom-defined variables, var_x and var_y, by placing the explicit values as command line positional parameters. Later in the script, I divided those values in order to calculate the coordinates of the middle of the screen. It all starts clearing up the screen, and it goes on with placing the current prompt position in the middle of the screen. Then we move back a few characters to try to match the length of the displayed message. I used a trick and actually collected the operation in one of my own variables, if you remember the third method of assigning values to variables. And then bang, we fire up the message in the middle of the console screen. So what do you think? Would you give it a try on your own console? Movement of the cursor is also available via some particularly interesting cap names. This is how interactive text-based dynamic displays were made available for utilities like the Midnight Commander. Once again, before you put them into production, the specific app names for your terminal type must be checked against the terminfo database for applicability. It is recommended to do this due to the fact that not all terminal types support the same cap names. Our feature inventory hasn't finished yet. We're going to find out facts about another powerful utility of the terminals in Unix, the STTY command. This is similar to typeset in that it can control terminal characteristics. But we have to know that potentially STTY is more disruptive to the user's terminal session and should be used with great care. This command does not rely on the terminfo database. Rather, it deals directly with the device controls used by the shell and the Unix kernel itself. A more complete list of settings can be displayed by calling the command with the -a option. Among the multitude of characteristics that can be controlled with the STTY, there are the following. Special command line control characters such as interrupt and erase. Hardware flow control such as baud rate and device handshaking. Basic output characteristics such as on-screen echo and output of lowercase and uppercase. All these words you can see on your screen are mnemonics associated with different display controls and console behavior controls. If a terminal setting requires a value, use the STTY mnemonic value syntax, in which a setting is either on or off, depending on whether or not the mnemonic word is preceded by a dash character as shown in this example. We use STTY here to disable characters displayed using the mnemonic echo in a print-read combination. This is useful in situations when sensitive information is requested by the shell script, such as passwords or security IDs. Prompt some message to make the user aware with what is going to happen. Given the fact that the default setting is on, turn off the screen echo for console-typed characters. Collect the desired information from the console input and keep it in a variable. The shell will still be able to read the typed characters. They are just not displayed for the user. Then, turn back on the screen echo feature for getting back the normal behavior of the console. End up by printing the information you collected. It's a pretty simple scenario. Remember, as with typeset, if a terminal characteristic is set by STTY, it remains in force until it is unset, regardless of whether the script that set the characteristic has terminated or is still running.